Hello everyone. So as we completed the chapter number 12, that is electricity, here are some of the illustration or the examples given in your textbook that I am going to solve today. Fine, and I hope you are clear with all your theory portions as well as the derivations. I remind you please go through repeatedly through this chapter because it is quite important. Okay, the series combination and the parallel combination of resistance, electric power, the heating effects of electric current, the definition of electric current as well as potential difference. Each and everything is quite important. You will be asked in the examinations, so you please go through this. As well as in physics, this lesson is also there in the portion of numericals. So you also need to pay attention on the numericals, not only on the theory. Fine. So I am going to study few examples of the chapter number 12. I have written here the direct questions and not the whole questions so that we can solve it easily. But you go through over here. I have written over here the example number 12.9 in your textbook. Fine. This is example number 12.9 in your textbook. Fine. So let us see the first question. Okay. The thing is, we are given a circuit and that is in the combination of series as well as parallel connection. Fine. It is in the combination of series as well as parallel connection. So students, you can see over here there is a battery whose potential difference is 12 volt. Whose potential difference is 12 volt. And if the electric current is going through here, there are two resistors over here and three resistors over here. Okay, we need to find the equivalent resistance. Fine. What we need to find? We need to find equivalent resistance. Stands for the resistance which is common to all. That means we need to solve the circuit. Fine, that means we need to solve the electric circuit. I am going that for this now, you please pay attention over here. As I told you that the electric current goes from positive terminal towards the negative terminal. So over here there are two resistors. As you can see that when electric current reaches over here, it divides into two portions, that is over here and over here. Again they will be over here and then they will mix with each other. Fine. I hope you are clear with this resistance 1 and resistance 2. Then these both are in parallel connections. I hope you know the formula for parallel connections. Let us say the mixture of both as 1 upon r prime. 1 upon r prime is equals to 1 upon r1 plus 1 upon r2. Fine. See the values of r1 and r2. The values of r1 and r2 is 10 ohm and 40 ohm. Okay, so what we need to do? Substitute the values. 1 upon r prime is equals to 1 upon 10 plus 1 upon 40. Okay, we know the LCM of 1 of 10 and 40, that is of course 40. Then we can write over here multiplied by 4 multiplied by 4. Okay, so this will be what? 1 upon r prime is equals to 4 plus 1 whole upon 40. Because as the denominator becomes same in both the equations, we can add up the numerators. And so this becomes 4 plus 1 upon 40. Fine. Now what happens if 1 upon r prime will be your 5 upon 40. 5 upon 40. So what we can write over here? We can reciprocate this. So that becomes r prime is equals to 40 upon 5. You know this thing, and this is 8 ohm. So we got the values of r prime, that is 8 ohm. What was r prime? That was the combination of resistance 1 and resistance 2. Fine. So what we need to do is we will make easy this circuit as by removing this parallel connection, we will directly write the values of this and that is R prime is equal to 8 ohm. Fine students, I hope you are clear with this. Now again we are going from here over here. Okay, now these are the three resistors which are also in parallel conditions. How you can know that? Because once the current reaches over here, it divides into the three form, 1, 2 and 3. Okay, and so if the voltage divides, the current divides, that means it is parallel in connection. Again we will suppose what? Say I am telling R double prime. Okay, then that will be 1 upon R3, 1 upon R4 plus 1 upon R5. Okay. Now we know the values of R3, R4 and R5. I have written over here 30, 20 and 60. Write these equations. So that becomes 1 upon R prime is equals to 1 upon 30 plus 1 upon 40 plus 1 upon 20 plus 1 upon 60. Fine students, I hope you are clear with this. Now we know the LCM of 30, 20 and 60. If you don't know, you can also find the LCM by simple prime factorization method. Okay, now the LCM of 30, 20 and 60 is 60. So we need to keep common. We can multiply 20 with 3. Then in numerator also we need to multiply it with 3. We can multiply 30 with 2. Then you can also multiply numerator with 2. So this, what happens? 1 upon R double prime will be 2 plus 3 ones are 3 plus 1 whole upon 60. Fine. So this becomes 1 upon R double prime is equals to 6 upon 60. Okay students, I will reciprocate these values, so that becomes R prime is equals to 60 upon 6. And so this becomes 10 ohm. So this becomes 10 ohm. I hope you are clear with this. R double prime is equals to 10 ohm. So now what we can do is, we can remove this R3, R4 and R5. If we are removing this R3, R4 and R5, this will be a common circuit over here named as R double prime and value is 10 ohm. Okay, I hope you are clear with this. What is the next step we need to do? See students, if the voltage is over here, that is the potential difference, and electric current is passing like this in these conditions, now R prime and R double prime are in series connection. R prime and R double prime are in series connection. So what we need to do? R is equals to R prime plus R double prime. Okay, so what we will do? R is equals to, what is R prime? 8. What is R double prime? We got 10. We can add these things, this is quite easy, and so R becomes 18 ohm. And so the R becomes 18 ohm. So the equivalent resistance is 18 ohm. This is the final value of resistance. One more thing what we can do is, if the potential difference 12 is given over here and the equivalent resistance is also given, we can also find the electric current by using Ohm's law. We know the Ohm's law. What is Ohm's law? Let us see that. If V is equals to IR, we can write I is equals to V upon R. Now what happened? Substitute the values of V, that was 12. Substitute the values of R, that is 18. We can cut these things by 2 upon 3. And so the electric current passing through this is 2 upon 3 ampere. 2 upon 3 ampere. Fine students, so this was the example of combination of series as well as parallel connection, as well as we need to find the electric current passing through this. Okay, I hope you are clear with all these things. First what I did, I take the two combinations that were in parallel as R prime. and named it as 1 upon r prime is equals to 1 upon r1 plus 1 upon r2. Okay, then I find the values of r prime and then I write for r double prime. Here the r double prime was the combination of r3, r4 and r5, and so I did the same and find the answers of r double prime, that was 10. Once the r prime and r double prime I am getting, and that is the combination of series connection, so what I need to do is r is equals to r prime plus r double prime, and so this becomes r is equals to 18 ohm. And so if V is equals to IR, I is equals to V upon R, I found the values of electric current. Okay. I hope you are clear with this. Let us move on to the next sum that I have written over here. Here also I have written in very short because I need to do the rest more work. Example number 12.10 in your textbook. Find these are the illustrations or the examples given in your textbook. So you need to read the questions from that and then you can know the exact sum. No doubt I will give you the clear idea about these things, but still, fine. Okay, let us go through this. See, over here I am giving you that the first power, the maximum power in any electrical conductor is 840 watts. As you all know and you should remember that the SI unit of electric power is watt. The SI unit of electric power is watt. Okay. So the maximum power given is 840 watt in a conductor, and the minimum power given in a conductor is 360 watt. It is 360 watts. Okay. And the voltage applied is 220 voltage. We need to find the electric current in the first power, electric current in the second power, resistance in the first and the resistance in the two. I hope you are clear with these things. Okay, so let us start this. You know the general formula of power. Yes, that is what? P is equals to VI. Name this as P1 is equals to VI1. What we need to find? I1. Write this as I1 is equals to P1 upon V. Okay. If you want to find electric current, I2 is equals to what is P1? 840 divided by potential difference is 220. Cancel these 0 zeros. Cancel this with 2, so that will be 42, and this will be cancelled with 11. So the electric current I2 is equals to 42 upon 11 ampere. Sorry, my mistake. This is I1. Okay. There is no mistake in calculation, of course. So I1 is equals to 42 upon 11. I1 is equals to 42 upon 11. What we need to find now? Resistance, that is R1. Okay, we need to find R1. So what we will do? We know the general formula. V is equals to IR. Now we are having V, we are having I1, so we can find R1. And so the formula becomes R1 is equals to V upon I1. Okay, V upon I1, and so R1 becomes, what is V? 220 voltage whole upon 42 upon 11. You know students, the denominators of denominator went over to the numerator, so you can write over this 11. Okay, again you need to do the same thing. This will be cancelled out by 21, this will be 11. So R1 will be something like 1210, because 11 is 121, 0 as it is upon 21 ohm. Please solve this in the form of denominator or point or decimal thing. Okay, I am leaving this as it is. So I hope you are clear with this. P is equals to VI, so P1 is equals to VI1, I1 is equals to P1V. Substitute the values of I1 and so you will get this. And then I1 is equals to 42 upon 11 amperes. Okay, and so V is equals to I1 R1. and so R1 is equals to 11 into 11 upon 21. So 1210 upon 21. Okay students, I hope now we are clear with this thing and this thing. Now we need to solve for I2 and R2. I2 and R2. Let us go through this over here. Again the formula is what? This sum is continuing over here, okay? Keep this thing aside. So what happens? Again P is equals to VI. Fine. Right? P2 is equals to VI2. We know that I2 is equals to P2 upon V. We need to find I2. What is P2? That is the minimum, that is 360 upon voltage, that is 22. This 0 gets cancelled out. This will be 18 twos are, this will be 11. And so I2 will be 18 upon 11 ampere. Don't forget to write these units. Please don't forget to write these units. Okay. And so I2 is equals to 18 upon 11 ampere. Now what we need to find? Now we are done with this. We need to find the resistance. We can write R2 is equals to what? V upon I2. I hope you are clear with this. So R2 is equals to what is V? 220. What is I2? 18 upon 11. But this 11 we will remove and multiply it over here. This will be with 9. This will be again with 11. So R2 is equals to 1210 upon 9 ohm. So students, this is your final answer. This is your final answer. You please solve this in the form of normal division to get the answer into the decimal form. Fine. So this was the example number 12.10. I hope you are clear with this. If you are having doubt, you can please contact me. Okay. So we will move on to the next thing, and that is example number 12.11. I have written over here. Okay, I hope you are clear with this. I am removing this part. Okay, fine. Okay students, so what is the third question given over here? That is example number 12.11. Example number 12.11. Okay. Now over here we have given the heat. We know the heating effects of electric current when the electric current is dissipated directly into the form of heat is known as heating effects of electric current, is known as heating effects of electric current. So H is equals to 100 J. Now what is time? Time is equals to 1 second. They have given us. Okay. They have also given us the resistance, that is 4 ohm. What the thing we need to find is the electric current and potential difference. That is the electric current and the potential difference. I hope you are clear with this. We know the general formula of heat. What is the general formula of heat? The general formula for heat is H is always equals to I square RT. Okay. H is equals to I square RT. What is heat? That is 100. What is time? 1 second. And what is resistance? That is 4 ohm. Okay. What we need to find? Electric current. So from the formula H is equals to I square RT, we can make the subject of formula electric current, and so electric current will be I square is equals to H upon RT. Okay. Now what was heat? That is of course 100 joule. What is resistance? That is 4 multiplied by what is time, that is 1. So you can cancel these students with 25, and so I square becomes 25. But I need only I, because we cannot keep this square as it is, and so I need to remove this, and so we will write I is equals to root 25. So the root 25 will be what? Of course 5. So electric current I is equals to 5 ampere. So this is your answer. Please check this out. If you are having any doubts, you can please tell me next time. Okay. The formula was H is equals to I square RT. Then I make the subject of formula, that is I square. And so I got the H upon RT, and I found I is equals to 5 ampere. Okay. So we are done with the electric current. Now we need to find the potential difference, that is V. According to the Ohm's law, what is Ohm's law? V is equals to IR. Okay. V is equals to IR. What we need? We need V. So that will be V is equals to I. I is what? 5. I is what? 5. Okay, and what is resistance? What is resistance? That is 4. So 5 4s are 20, and so potential difference V is equals to 20 voltage. We are done with this. Okay, this was also your answer, and this is also your answer. Okay, so if they have given anything in the form of heat, we can find anything, that is resistance, electric current, and from the resistance and the electric current, we can also find the potential difference. Okay, so I hope you are clear with this example, that is 12.11. Okay students, next question what we are going to see is this. And that is prove that sum. We need to find the resistance, no doubt, but it is a type of prove that, so you please pay attention over here, but it is very easy, quite easy. That is the example number 12.6, and that is the example number 12.6. What they are telling in the question is, there is a wire and that is having a length L centimeter. Okay. And the area of it is A. Area of it is A. Okay. The resistance in which it is flowing is known as to be 4 ohm. So you can write over here that length of a wire, say L1 is L, area 1 is A, and resistance 1 is 4 ohm. Okay. Now what they are telling, we need to find the second resistance if the same length of the wire is cut into two parts, that is L upon 2. So if we are dividing a length L into two parts, so that will be L upon 2. That will be L upon 2. And if the area is half, the length is half, the area is double. The area is double. That is area is equals to 2A. That is the area is equals to 2A. Fine students? Then we need to find the resistance. So I can write over here length 2 is equals to L upon 2 and area 2 is equals to 2A. We need to find R2. Okay. So what happens? We know the general formula of resistance. R is equals to rho L upon A. Okay. Now what is L1 over here? Say this is R1, L1, A1. Now what is the value of R1? The value of R1 is 4. The value of R1 is 4. Keep this rho, that is the resistivity, as it is. What is the value of L1? That is L. What is the values of area? That is A. Name this equation as number 1. Name this equation as number 1. Okay. So 4 is equals to rho L upon A. 4 is equals to rho L upon A. what we need to find? We need to find resistance number 2. So the formula over there will be what? R2 is equals to rho L2 upon A2. Okay, we need to substitute the values of length and area. We are not having R2. So write this as R2 is equal to, keep rho as it is. What is the value of L2? That is L upon 2. Right. L upon 2. Okay, what is the size of the area? 2A. What is the size of the area? That is 2A. And so this becomes R2 is equals to rho L. As I told you, denominator. This is the numerator's denominator. So it will land over to the denominator. Then you can multiply this 2 and 2. And so this becomes 4A. This becomes 4A. State this as equation number 2. Students, you can see the similarity over here. What similarity? In the first equation, I am having the values of rho L upon A as 4. Okay. The values of rho L upon A is equals to 4. Then I am also having this, and I can write this as this. R2 is equals to 1 upon 4 rho L upon A. Okay. I separated this. See, there is no change between this R2 and this R2. This is rho L upon 4A. This is 1 upon 4 rho L upon A. Now instead of this rho L upon A, I can write the values for. I hope you are clear with this. Instead of writing rho L upon A, I will write equation this. So what I will do? Instead of this 1 upon 4, I will keep as it is. But instead of rho L upon A, I will write 4. I will write 4. And so what happens? 4 gets cancelled out. And thus the resistance will be R2 is equals to 1 ohm. Because over here 4 gets cancelled out, and so answer is 1 ohm. I hope you are clear with these things. Okay students, I hope you are clear with this, how I did this thing. There was a length of wire L and the area was also A, and the resistance was given as 4 ohm. So first of all I wrote the equation, and that is quite common to you. R1 is equals to rho L1 upon A1. Okay. Then what I did? Instead of R1 I wrote 4. So 4 is equals to rho L upon A, because L1 was L, area 1 was A, and then R2, and I stated this equation as number 1. Okay. So now R2, what is R2? The length was half, area was double. So length was half, that is L upon 2, area was double, so 2A. And so R2 is equals to rho L upon 2. I substitute the values of L2, okay? And A2 instead of that I wrote 2A. So R2 is equals to rho L upon 4A, because these 2 and 2 gets multiplied. Now I was having the values of this rho L upon A over here, that is rho L upon A. And so this rho L upon A is equals to 4. I substitute the values of R2 is equals to 1 upon 4 into 4. Then 4 gets cancelled out. And so this is equals to 1 ohm. And so R2 is equals to 1 ohm. I hope you are clear with this. I also hope that heat numerical is also clear, as well as the series resistance what we did. Okay. So this was all for yesterday. If I am having many more sums, we will be solving over here. If you are having any doubts and queries, you please let me inform. Okay, thank you.